Thank you everyone for joining. Lynn, actually, why don't you start the presentation?
Yeah, we've seen the title. First, we'd like to acknowledge our team members. Here show the main contributors to the project. This work really exemplifies a collaboration, actually an interdisciplinary collaboration between the energy technology area, ETA, and the science IT. Next, please. A little bit of background about the project. I know this is not a science talk. I'll keep it short. As part of the effort to combat climate change, California has set ambitious goal to divert 75% of organic waste from landfill by 2025 in order to reduce landfill methane emissions. This requires significant growth of organic recycling industries in a very short amount of time. However, the industry often faces many barriers to make the scale up economically and environmentally feasible. Our project is here to help. One of the barriers is the odor issue. In fact, the biggest cause that people do not want to have a next waste processing facility built next to their house is because it stinks. Our study site, ZWED, as shown on the map here, was the largest dry anaerobic digestion facility in the US when it's constructed. It's located near the southern tip of San Francisco Bay, just upwind of three major cities, San Jose, Milpitas, and Fremont. ZWED was initially operated at half of its capacity, and now they want to scale up, grow to its full capacity and even beyond. However, the odor issue is already notorious in the downwind city Milpitas. If you ever drive by there, you know what I mean. To address the odor issues, next slide, please. Part of our effort is to simulate the odor concentrations at its downwind receptor locations using a plume model called AirMod. At the end of the day, we want to provide an interactive map like the next slide to support decision makings on proper siting and scale up of such facilities while minimizing the impacts on the local communities. Ting, now it's your turn.
Thank you, Lynn. So I'm going to talk about the actual step that we use to create an interactive map. These are roughly the outline we're going to follow, which is essentially taking the textual data that is available in the spreadsheet in the text file, and then geocoding in a specific format, and then putting in a web-based, cloud-based server called Mapbox, and then creating a website for it, and then showing it interactively to the users, which is actually part of the requirement for this project. So to get started, we use a tool called Mapbox. If people have used Google Maps, you're very familiar with something very similar. This one can also be used for a lot of applications that need to actually place data in the map in addition to just helping people route and navigate in a city. They have a lot of examples in the website. For example, they show like bubbles of different sizes for varying amounts of data in those bubbles. You can have heat maps. But in our case, we actually have a uniform grid of data that kind of look like what they may have shown in here. Mapbox, in this example, used the different logos to present where the data are. We actually want to do essentially is color code the data depending on how much the odor is going to be perceived by the users downwind from the CWED websites. So as I mentioned earlier, from the modeling and simulation data that Lynn and her coworker has done, they have essentially CSV files with a whole bunch of data points, and in those data points, there will be concentrations for the odors for them. Because of the way how we want to use Mapbox to present data in a uniform grid in the plume data that you saw in the previous example, we actually needed to convert the data from a single point into a polygon. And so we know that our data actually are 50 meters apart, and so we can actually calculate the coordinates for how big that data grid is. And from there, we can create a 4-point vertex that encloses the area and convert it into a larger tabular data file like the one in the bottom. And the next step would then be converting it into a specific format called GeoJSON, which is essentially a JSON file with latitude and longitude embedded in it. This is an example with 2 points in it. The concentration is in the first red square. Then the second thing is actually, because the GeoJSON doesn't actually expect a square, it's actually just any arbitrary polygon. So we end up having a 5-point vertices. And the last point is actually being the first point so that it closes the polygon. And this is actually the format of the data that would need to be fed into Mapbox. We have written a script that is available on the link that you see on the screen. And essentially you run a Unix command, you cat your original source file, you send it to a conversion script, and you get a resulting GeoJSON. Once you get that GeoJSON, you will log into Mapbox and upload that data into Mapbox. Mapbox is a website, it's a web-based interface, and you go to mapbox.com, you log in, you see a little bubble on the upper hand corner, you click on it, and you click on a thing called Mapbox Studio. And that will bring us to an interactive development environment that looks like this. It's actually hidden by this screen here, but the first thing you will need to do is click on tile sets, then click on a button called New Tile Set underneath this icon here, and a dialog box like this will pop up. You will click on Select File, and you can then navigate to your computer to locate where the GeoJSON file that you generated from the previous step and upload it to the web server here. Once you upload that file, there will be a little notification icon here in the bottom. You can click on it and expand, and you actually tell you what is the file tile name that was generated. Pay attention to that because you will need it in the next step. Moving on. After you have uploaded data, then we want to create a maps with some styling that we want for the map, and then place the data as an overlay on top of that map. Mapbox again makes it really easy. They have a whole bunch of very nice, pretty looking maps, and you can actually customize them with different color scheme that you may want, depending on what works better for you. This actually satellite data map also. Once you pick the basic map layer, we want to add the data layers to it. And by essentially continue the Mapbox Studio, once you load the correct style, you then click on Select Data and load the data that you uploaded as a GeoJSON file. In our case, I mentioned earlier, we have a uniform grid, and this is actually kind of zoomed out, so it doesn't see a lot of details. I'll move on to the next slide. If I zoom in more to the data, you see that it's actually a uniform grid of data where our data stuff is placed. We're going to use a data styling based on the number value that is inside each of the grid. And in this case, Mapbox is essentially calling it fill the polygon with a specific color according to the weights that is inside the polygon. So here's a hypothetical data that we uploaded during the development cycles so that we can help visualize that the data can be graded according to different grading colors. This max here is actually according to the unit that we have in maximum concentration in our GeoJSON file that we coded earlier. After you have done all of that, then you can publish your maps. In your home screen of the Mapbox Studio, there's a little icon next to the map that you created, which is kind of like a share. You click on that, you scroll down and to the developer resources, and you will see a couple of options about that is specific to the map and the data layer that you have loaded. These are data that we will need to use in the next step. Historically, they actually have a button that says generate a web map page HTML based on this data. I don't know why they took that off last time when I checked it. And so you have to go to their documentation page listed here at the top, and you actually have, you will see all the code that you need to actually create an HTML file. It's not actually overwhelming. It's actually just the code that you see here in the red box. And you essentially can cut and paste those things into a text file. Like I'm using Notepad++ here, and then paste those code here. You add a couple of tags, HTML in the beginning, HTML in the end. The little square area is actually from a couple of slides ago when I mentioned that when you generated your own specific map, it will have given you an access token and your style URL in that area. So once you copy the code from the example web page, you will paste those like filling up a form and using the code that is specific to your website. We have also here coded the latitude and longitude and the default zoom level for our map. You can change it to according to where you need the map to focus when the web page first load. We also have the web page here to say that we want the map to be 800 pixels by 600 pixels. And if you want any arbitrary text explaining what your thing is, your map is showing, you can put those texts here in the HTML file. And once you do all that stuff, you save this, it's an HTML file, and you can either double click on it on your local computer, which is going to load up as a web page like this, or we can then upload this HTML page to a web server to be served out on the web. And this is just showing the example data we have uploaded. Here in this slide, actually, we're showing a slightly more complicated example, which is actually what we did in the project. We actually have some menus that actually you can drop down to select those differing seasons of data. You hover over the mouse on the actual website listed up here, you will actually have numbers that was actually in the grid. Some of these things actually require a little bit more programming. It's actually essentially doing JavaScript. For those who is actually familiar with that, they can add those JavaScript into HTML page. There's a legend here, but you can actually also do the legend as part of your text file in your HTML page. And if you need help with those things, reach out to us and we can help with those things. But this is the kind of thing that you can actually do with Mapbox once you place all the data on the web in the cloud. And then just actually to wrap up the slides, I have a couple of steps here that actually talk about how to actually use GitHub to act as a web server for your HTML page. And then thanks to the folks in LBL Network IT, LBL Net, there's a web page that you can actually request a URL with the lbl.gov name in there. For example, we create our website calling it smelly.lbl.gov. So I'm just going to run through this real quickly. There's a website called ip-request.lbl.gov. You go there, make sure you click on the advanced interface, and you will bring up a site like this. You can put in your name, you can hit next, and you actually query whether the name is available. If someone else has already taken it, if you type in Smelly Willy, you actually complain actually ask you to log in to manage the existing record rather than create a new one. Essentially, you tell the DNS web server administrator that you want to create CNAME record, which is in DNS an alias to what you're going to host in GitHub. This part is actually some of the clever thing that the LBLNet actually team has done. The website ended up being hosted in this thing called Cloudflare, which actually has wide distribution across the globe, and you actually tolerate denial of service attack to your website and stuff like that. And actually all these things free to us, to the user of this. But when you submit the thing, you can just kind of fill in the actual URL from website and add this static text in the end. There's a person actually in the backend processing this thing. If they have questions, they'll actually reach out to you and ask clarifications. The next step is actually say, submit the CNAME request, put the actual GitHub URL in here. And I know, actually, let me show the GitHub page. So you essentially create GitHub repository like any of your other code. You place HTML file in there. You go to the settings page, and then you say generate GitHub pages for it. And you will give your URL. By default, is github.io with your username in it, and then you say that actually I want a custom domain, and you put in the domain that LBL is available for you to use. You hit save, and actually once you do submit all this thing, you go to the website, you type in smelly.lbl.gov, you will actually look up in LBL DNS, redirect to Cloudflare, and get access to your webpage. And essentially all this thing is available for free. Here's actually a couple of tutorials links from Mapbox about what we have covered in here, and you want a copy of the slides, it's actually available in this link. And I think I'm close to the question time. And if anyone has any questions for me or Lynn.
All right, thank you. Yes, there is a couple of questions here. Let's see. How does this compare with trying to generate maps in Google Maps?
I have actually myself not used Google Maps. I have talked to some other people who actually work on similar projects before. First of all, Google Maps is a lot more expensive. Mapbox is not entirely free. It's just that I'm going to go back here to my initial login page. It's just that Mapbox provide a very generous free tiers. When you first log into Mapbox, they will actually show you how much requests you can have each month for free. And our website is for scientific use. It's mostly used by people from the California Energy Commissions and people who are actually trying to develop garbage to energy websites. So we don't get a lot of traffic. You can see that we are like not even 10% of the free allowance that they gave us. If you go to Google, especially recently with the price hike, their stuff is very expensive. And if you want to do routing stuff, the generic, mobile user stuff, Google Maps is actually great. But if you want to do a lot of the map data, interactive data analysis, showing data on a map for users, a lot of the election map that you see on the website is actually backend by Mapbox, or they use a API underneath it called Leaflets. And so either you host it by yourself or you can have Mapbox hosted on the cloud for you. Most of the people who actually do interactive data analysis use this API instead of the Google API.
All right, and another question that was asked is, does Mapbox have an API to update the data automatically, potentially from sensor equipment?
So Mapbox actually does have an API, and the way how we approached this project in the beginning, we used Mapbox Studio as a web interface to kind of look through all these things. But you might have seen some of these things here, we actually have hundreds of data tiles in the background here. And yes, they have an API that you can use to program to upload all this data. You will have to learn how to use the API. It's actually very well documented. Whether you can actually do this thing on live sensor data, that's probably a little bit trickier. I would imagine it's definitely very doable as a batch process. If you have have your sensor data collect as a file, and every night you have a process that runs and create a geolocation and upload those files into Mapbox, I would imagine that's doable. If you actually want this thing to query live data from the sensor, I am not so sure. I haven't done that. It's probably possible. I just don't have that answer for you. Sorry.
That's all right. Another question. Is there an access limitation per month for the free Mapbox API?
So I believe they haven't actually even asked for my credit card information. I believe actually if you go over the limit, they just essentially start charging you. But the fact that they don't have a credit card, I actually haven't run into that, whether they will actually stop servicing that you have run out of your quota and cannot serve, or most likely, I believe they actually should just be like billing you. And if you have somehow have a huge, very popular website, potentially you can rack up a lot of charges, just like Amazon Web Services and Google Cloud Services.
All right, that's all the questions I see right now. Ling, did you have any other points that you would like to make?
I'm very grateful for the team to help us create this web tool. It's our founders, California Energy Commission, was very happy with this web tool. It's really like a beyond the scope of our like a promised work scope. So yeah, I just want to take the opportunity to thank team again.
Thank you for the opportunity to work on this.